In the last video, it was hinted that it wasn't rational to have a radical in the denominator, so we need to take a look at how to divide denominators, or how to divide radical expressions, and basically we need to rationalize the denominator. So here's a few problems to help us out. The first one says the square root of 17 over 6, which is basically another way of saying the square root of 17 over the square root of 6. So to remove the radical sign from the denominator, we need to multiply by a factor that will make the denominator a perfect square, and since it's in a fraction, we need to multiply the whole thing by the same number, the numerator and the denominator, a factor of 1 basically, so we don't change the value. And so it's just easy to take a look at, or it's just as easy to multiply the numerator and the denominator by radical 6. In the denominator, we'll get radical 6 times radical 6 is, we'll just say radical 36 for now, and 17 times 6 will be radical 102. So the square root of 36, so that's just 6. So our answer will be the square root of 102 and then over 6. So now we have rationalized our denominator. This number is equal to that number, but with a rational denominator. Let's take a look at number 6 here. We have a number that's already outside the radical, so when we go to rationalize our denominator, we don't really need to worry about that. All we need to do is multiply by this radical 2, and we'll do it by a factor of 1. And that'll give us 3 radical 10 over 8 times 2, or 3 radical 10 over 16. So what we have to do now is rationalize a denominator with a perfect cube number. So 6, to make it a cube number, we need to multiply it by 6 squared, so we'll multiply it by 36. And x to the 4th power needs to be multiplied by x squared, so it would be x to the 6th. So let's do that again up here. 36x squared. Let's see, 36 times 2 is 2, carry the 1, 6, 72. The cube root of 72, x squared y to the 4th power, and that'll be over the cube root of is 216. X squared times x to the 4th is x to the 6th power. Now, here's what's cool about this one. This one, we still have some simplifying we can do, not only in the denominator, which we kind of rigged for ourselves, that'll be 6x squared, but also in the numerator. See, this this y to the 4th power, well, that's y cubed times y. So the y cubed has to get out of jail free card. That'll be a y outside of the radical symbol. But let's take a look at 72. 72, let's prime factor that. Prime factoring is so much fun, and it's our friend because it tells us so much about our numbers. Aha! Now I can continue prime factoring, but I know that 9 is going to stay right where it is inside that cube root symbol. 72 is 2 to the 3rd power times 9. See, here's my 2 to the 3rd power there, times 9. So the 2 has to get out of jail free card, so it'll be 2y times the cube root of 9x squared. Mind you, that y is not cubed, it's the cube root of 9x squared, all over 6 x to the 2nd power. So that one was nice and fun. Let's try a couple more. Number 22 says the cube root, it's 3 over 8 cube root of 5. And here, again, if you watch the last video, you saw that we did conjugates, radical conjugates. So the radical conjugate of 8 plus radical 5 is 8 minus radical 5. And then that will, in the denominator, 8 minus radical 5. That will give us, in the denominator, 64 minus 5. And in the numerator, it'll give us 24 minus 3 radical 5. And 64 minus 5 is 59. And in the numerator, we've got 24 minus 3 radical 5. Let's take a look at one that has another radical expression that requires us to use our conjugate. Our conjugate in this case would be radical 5 plus radical 2. And we'll multiply that by the numerator and the denominator, plus radical 2. And in the denominator, that's the easy part, that gives us 5 minus 2. And in the numerator, let's see how this works. 5 times radical 5 is radical 5 squared, plus radical 10 minus radical 15 when I did those two already. Now let's do these two here, minus radical 6. So this is really quite a rack here. Now with the numerator, there isn't going to be much I can do there except deal with this guy here, and that's just 5. So it'll be 5 minus plus radical 10 minus radical 15 minus radical 6, and all of that is over 5 minus 2, which is 3.